everyone. Thank you very much for signing in and watching my live stream. I'm Mr. Matt, and this is Dr. Tot. Dr. Tot, cookie for class. Very good. And welcome to SAT ACT Prep. We're going to continue with some miscellaneous drill sets, and today we're going to concentrate specifically on the difference between taking a percent, increasing or decreasing by a percent, or calculating percentage change. Those are three entirely different mathematical concepts, and you need to be comfortable with them for both exams. So let me go ahead and share my screen with you. And just a reminder, this is a live stream, so there's a little bit of a delay, but I'll try to make the best of that and make sure that doesn't get too much in our way. So I'm going to give you 6 minutes to look at the following 3 questions, and about 2 minutes in, I'll start to solve. So 6 minutes, I'll keep track of the time in the upper left-hand corner, and I'll update it per minute as close as I can. Okay, so go ahead and try these 3 problems, and then we'll go through a complete review. Okay, so let's go through these. First of all, so each one of these questions represents the different strategies I outlined in the beginning of the video. Number one is taking a percent, number two is increasing or decreasing by a percent, and number three represents calculating percentage change. So for number one, in a large jar containing 3,000 marbles, 30% are blue, 20%, oops, excuse me, sorry about that. 30% are blue, 20% are red, and the remaining are green. What is the difference of the number of green marbles and the number of blue marbles? So in order to calculate the number of individual marbles there are of each color, we need to take the percentage relative to the total number of 3,000 marbles in the jar. If we wanted to calculate the number of blue marbles, we would just turn 30% into a decimal by moving the decimal place 2 places to the left. So right now, as 30 has a decimal place to the right of 0. Moving it 2 places to the left would give us 0.3. So 0.3 is the decimal equivalent of 30%. If we take 0.3 and multiply it by 3,000, the total number of marbles in the jar, we get 900, and that's the second step in blue for number one. Green is a little bit trickier to calculate because they don't outright give us the percentage that are green, the percentage of green marbles in the jar. However, they give us the other two parts, the other two colors of marbles, blue and red, and they say that the remaining are green. So if we have 100% of the 3,000 marbles, in percentage terms, 100% means the whole value. So whatever it is, if you have 12 apples, you have 100% of 12 apples. If you have 3,000 marbles, you have 100% of 3,000 marbles. So if 30% are blue, that means that there's 70% that are non-blue. If then 20% of those non-blue marbles are red, that means there's a remaining 50% that are green. So ultimately, through that calculation, I have 1 minus the quantity 0.3 plus 0.2. That's the decimal equivalence of 100% minus 30% plus 20%, representing the other two colors in the jar. 3,000 times 0.5 is going to give us 1,500, and they ultimately want the difference between the number of green marbles and the number of blue marbles. So when we subtract 1,500, 1,500 minus 900 is going to give us 600. So the answer to number one was 600. Number two, a car audio system is purchased for $200 and subject to 6% sales tax. What is the final price of the audio system including tax? So here we're not taking a percentage of the cost of the audio system, because if we were to take a percentage, that would actually decrease the value, where we're really trying to add a percentage onto it or increase the value by a certain percentage amount. Here it's a 6% sales tax, so we want to multiply the cost of the audio system by 1 plus 6% written as a decimal. 6% written as a decimal, moving the decimal place 2 places to the left, would give us 0.06. So 1 plus 0.06 is 1.06. 200 times 1.06 will give us a total cost of $212, which is the answer to number two. And number three, an antique car was purchased for $5,000 and later sold for $20,000. What is the percentage change in the car's value? So to calculate percentage change, always, we have to take the final value minus the initial value divided by quantity divided by the initial value, quantity times 100 if they ask for a percentage answer. So the final value here is 20,000. The initial or starting value was 5,000. So we have 20,000 minus 5,000, quantity divided by 5,000, quantity times 100. So 20,000 minus 5,000 is 15,000. 15,000 over 20,000, they're both divisible by 5,000. 5,000 goes into 15,000 3 times. 5,000 goes into 20,000 4 times, leaving us with a reduced fraction of 3/4. 3/4 written as a decimal is 0.75. And so in the decimal form, our answer is 0.75, but they specifically ask for a percentage. So if you were to enter 0.75 as a grid-in answer, that would be graded as incorrect. It would be wrong because you really do, it's necessary to move that decimal place 2 places to the right, to the left, to the right, 2 places to the right if we're going from a decimal to a percentage. And so your answer here would be 75. If you entered in 0.75, that's a decimal answer that represents 0.75. That's a totally different number than 75 itself, the integer. If you have any questions, then please let me know either in the comment section or you can contact me on my social media accounts. But otherwise, let's go to the next set. So I'm going to give you 6 more minutes for questions 4 through 6. Question 4 asks, in a large jar containing 4,000 marbles, 10% are blue, 35% are red, and the remaining are green. What is the difference of the number of green marbles and the number of blue marbles? 5 asks, a car audio system is purchased for $150 and subject to 8% sales tax. What is the final price of the audio system including tax? And 6, an antique car was purchased for $18,000 and later sold for $180,000. What is the percentage change in the car's value? So I'll give you 6 minutes and update the time per minute. About 2 minutes in, I'll start to solve to give you some hints. Okay, so let's go through 4 through 6. So for number 4, we're taking percentages in order to calculate the individual numbers of each, the number of marbles in each individual color, rather. So there's a total of 4,000 marbles. Green marbles are all the remaining marbles, all the marbles in excess of 10% blue and 35% red. So if we take 100% minus 10% plus 35%, 10% plus 35% would be 45%. 45% written as a decimal would be 0.45. So we're going to take 1.00, the decimal version of 100%, minus 0.45. That's going to give us 0.55. So 0.55 times 4,000 is 2,200. So there's going to be 2,200 green marbles. 10% of 4,000 gives us 400 blue marbles. The difference represents the operation of subtraction. So if we take 2,200 minus 400, we get 1,800, which is the answer to number 4. For number 5, a car audio system is purchased for $150 and subject to 8% sales tax. What's the final cost? So if we take $150 and increase it by 8%, we're going to multiply it by 1 plus the percentage change. So 1 plus the 8% written as a decimal is going to be 1 plus 0.08, which is going to be 1.08. 150 times 1.08 is $162, which is the answer to number 5. And number 6, if we start off with a value of $18,000, and it increases to $180,000, then we're going to take the final minus initial divided by initial times 100. So 180,000 minus 18,000, quantity divided by 18,000, quantity times 100 would give us 162,000 divided by 18,000. 18,000 goes into 162,000 9 times, so that leaves us with 9 times 100, which represents a 900% increase. If you have any questions, then please let me know. Otherwise, let's look at the last cluster of these problems. I'll give you 6 minutes. Please look at questions 7 through 9. Okay, so for number 7, to calculate the number of green marbles in the jar, we first need to take 100% of all the marbles and subtract away the other two parts that we know of. We know what percentage of the marbles are blue and are red, and the remaining are green. So 100% minus 15% minus 25% is going to leave us with 60%. So if we take 60% of 5,000, we're going to find that there are 3,000 green marbles in the jar. For the blue marbles, they outright tell us that they're just 15% blue. So 15% of 5,000 marbles is going to be 750 marbles. 3,000 minus 750 is going to leave us with 2,250, which is the answer to number 7. Number 8, if we originally have a car system that's purchased for $350 and subject to a 7.5% sales tax, what is the final price including tax? So 7.5% written as a decimal is going to be 0.075. So that extra 0.5 in the percentage just gets tacked on to the end in the thousandths place in the decimal. So if we take 1 plus 0.075, that's going to leave us with 1.075. 350 times 1.075 is going to give us a total cost, including tax, of $376.25, which is the answer to number 8. And number 9, if we have an antique car that was purchased for $12,500 and later sold for $250,000, what is the percentage change? We're going to use final minus initial divided by initial times 100. So the final value, 250,000, minus the initial value of 12,500. Quantity divided by 12,500, quantity times 100 if we want our answer to be in percentage terms. 250,000 minus 12,500 is going to give us 237,500. 237,500 divided by 12,500 is 19. 19 times 100 is 1,900. So this represents a 1,900% increase in value for the car. If you have any questions, then please let me know. Otherwise, let's go on to a new set or a new pair of percentage problems. These are going to be a little bit trickier, a little bit more involved word problems. I'm going to give you 6 minutes, and about 2 minutes in, I'll start to solve. Okay, so for number 10, at a certain university, 45% of the students are from New York, and 20% of the students from New York are athletes. If 40% of all students are athletes, what percentage of all the students at the university are not from New York and not an athlete? So what you can do as a starting position, because what they're asking for, they're only giving you percentages to work with, but they're also asking you just for a percent. So as long as you assume a value and do the correct arithmetic through each step, it doesn't really matter which value you start with. A good number are multiples of 100 or 100 or 1,000. Here, there might be a lot of different levels of division, and if that's the case, then you might want to choose a larger number, but usually 100 or 1,000 are really good numbers to take because it's very easy to calculate percentage change from 100. It's the only number, 100 is the only number where the percentage difference is actually the same as the difference from the number. All other values, you need to use that percentage change calculation of final minus initial over initial. But for that reason, 100 is a really good number to use or to assume as a starting value. Here I chose 1,000 because I didn't know how many levels of division we were going to go through, but because it's a multiple of 100, it also has pretty simple decimal calculations. So if 45% of the students are from New York, that means that 55% have to not be from New York. This is kind of like a bimodal situation or a bifurcated situation where it's either one or the other. A student is either from New York or he or she is not from New York. So if 45% are from New York, which I'm using a tree diagram to try and organize all of this information. I'm starting at the top with 1,000 students, and the first division of two branches from 1,000 is going to be either you're from New York or you're not from New York. From New York represents 45% of the students. 45% of 1,000 will be 450. So we have 450 New Yorker students. And therefore, there must be 55%. That means that 55% of the students must not be from New York. 55% of 1,000 means that there's 550 students not from New York. Of those, they say 40% of all students are athletes. So off to the side there, I have a way of calculating the total number of athletes at this university. It's 40% of 1,000, so I'm going to take 40% of 1,000. 0.4 times 1,000 is 400. So in total, there has to be 400 athletes. Then they also say that 20% of the students from New York are athletes. So on the left-hand side of this tree diagram, I'm going to split the students from New York into athletes or not athletes. And I'm going to do the same thing for the students not from New York. Are they athletes versus not athletes? If 20% of the New Yorker students are athletes, then I can take 20% of 450 to find that there are 900 students from New York that are athletes. So that allowed me to fill in the slot all the way to the left under athlete, and which is under New York. Now I know the total number of New Yorker students. So if I know how many are athletes and I know the total number of New Yorker students, then I can determine or calculate how many students there are that are from New York and are not athletes by subtracting. 450 minus 90 is going to give me 360 students who are from New York but not an athlete. Then I know that in total there's 400 athletes here. So if there's 400 total athletes and I subtract away the 90 athletes that are from New York, that means that 400 minus 90 is 310. There must be 310 athletes that are not from New York. So that allows me to fill into that second to last spot under athlete, which is under not from New York. And then lastly, what they're actually asking us for is for the number of, the percentage of students, of all students that are not from New York and not an athlete. So if there's a total of 550 students that are not from New York and 310 of those are athletes, that means that 240 have to not be athletes. So the final answer here, what percentage of all students, we would take 240 divided by 1,000, because we're assuming a hypothetical 1,000 total students. So 240 divided by 1,000 is going to give us 0.24, which written as a percent, which is what they asked for, is going to be 24%. If you enter in 0.24 as an answer here, that is going to be an incorrect. That's going to be graded as incorrect, rather. And number 11, I had to do that off to the side there, so let me scroll up. Actually, why don't I go ahead and just move this stuff down here for a second, so then I can, oops. Show this guy. So for number 11, a group of 20 friends go to their local ice cream shop for a summer afternoon treat. 60% of the friends get vanilla, and the other 40% get chocolate ice cream. Furthermore, three of the friends who chose vanilla ice cream also got sprinkles, and 4% of the friends who chose chocolate ice cream also got sprinkles. What is the percent of all the friends who chose chocolate ice cream without sprinkles? So if we, again, using a tree diagram to separate all of these pieces of information, because we can recognize at each level there is a bifurcation in the data. Either you chose vanilla or you chose chocolate. Either you chose sprinkles or you chose no sprinkles. There's no in between. So knowing one part and the whole allows us to calculate the missing part. So we have a total of 20 friends. They say that 60% of them get vanilla ice cream. 60% of 20 is 12. So there are 12 people who chose vanilla ice cream, represented by the V off to the first division on the left. Then we have chocolate on the right, representing 40% of all the friends. 40% or 0.4 times 20 is 8. So there are 8 friends who chose chocolate ice cream. They say 3 of those chose vanilla ice cream with sprinkles. So I put from vanilla, I now divided each of the flavors into sprinkles and no sprinkles, S and NS, just to abbreviate. So they give us that there are 3 people who chose vanilla and sprinkles. If I know that there is a total of 12 friends who chose vanilla, then 12 minus 3, or 9 friends, must have chosen vanilla with no sprinkles. Similarly, if they tell us that 4 of the friends who chose chocolate also chose sprinkles, and there are 8 total friends who chose chocolate, 8 minus 4 gives us 4 friends who did not choose sprinkles, who have chocolate with no sprinkles. So what percent of all the friends chose chocolate and no sprinkles? That's going to be 4 over the total 20 friends, which reduces to 1/5, which is 0.2, which written as a percent is 20%. If you have any questions, then please let me know. Otherwise, I'll give you 6 more minutes. Please look at 12 and 13. Question 12 asks, at a certain university, 48% of the students are from Maryland, and 30% of the students from Maryland are athletes. If 40% of all students are athletes, what percentage of all the students at the university are not from Maryland and not an athlete? Question 13 asks, a group of 50 friends go to their local ice cream shop for a summer afternoon treat. 30% of the friends get vanilla, and the other 70% get chocolate ice cream. Furthermore, 5 of the friends who choose vanilla ice cream also got sprinkles, and 10% of the friends who chose chocolate ice cream also got sprinkles. What is the percentage of all the friends who chose chocolate ice cream without sprinkles? So I'll give you 6 minutes, and after 2 minutes, I'll start to solve. Okay, so for number 12, if we assume 1,000 students just as a starting point, because they're only giving us percentages to work with and they're asking us for a percentage as an answer. So as long as we do the correct arithmetic, it doesn't matter which values we start with. But let's assume 1,000. So if they say that 48% of the students at the university are from Maryland, 48% of 1,000 would be 480. If then 30% of those students are athletes, 30% of that 480 would be 144 students are from Maryland and athletes, meaning that 480 minus 144, the total number of students from Maryland minus those students who are athletes, would leave us with 336 students that are from Maryland but not an athlete. If 48% of the students are from Maryland, that means that 52% are not from Maryland. 52% of 1,000 would be 520. If they tell us that off to the side, there are 40% of the total university students are athletes, that means that there's 400 athletes in total. We can use that information to calculate the number of students who are not from Maryland but athletes, because there has to be 400 total, and we already know that there's 144 that are from Maryland. So 400 minus 144 means that there are 256 students that are athletes and not from Maryland. If there are a total of 520 students not from Maryland and 256 of them are athletes, that means that 264 of them are not athletes. 264 students out of 1,000 students represents 26.4% of the student population. So that's the answer to number 12. Let me move that down here so that I can put in the other solution. So for 13, we have a group of 50 friends go to their local ice cream shop for a summer afternoon treat. 30% get vanilla and 70% get chocolate. So I'm going to split the 50 into one branch of the tree that represents the vanilla ice cream and the other branch into chocolate. So 30% of 50 is 15. 70% of 50 is 35. They tell us also that 5% of the people who chose vanilla got sprinkles. That means that 15 minus 5, or 10 people, chose vanilla ice cream with no sprinkles. 70% of the friends chose chocolate ice cream. So 35 friends, 35 people chose chocolate ice cream. They say of those 35, 10 chose to get sprinkles, which means that 35 minus 10, or 25 people chose chocolate ice cream with no sprinkles. 25 out of the total 50 represents 50% of the friends got chocolate ice cream without sprinkles. If you have any questions, then please let me know. Otherwise, let's look at 14 and 15, and these two questions will take us up to the end of class today. I'll give you another 6 minutes, and again, 2 minutes in, I'll start to solve. Okay, so number 14, at a certain university, 45% of the students are from Texas and 20% of the students from Texas are athletes. So if 45% of, let's assume 1,000 students are from Texas, that means that 450 students are from Texas, meaning that 55% of the students are not from Texas, in other words, 550. Of those, 20% of the students are athletes, from Texas are athletes. 20% of 450 is 90. If we know that 40% of all the students are athletes, that means that there are 400 total athletes. So 400 minus 90 means that there are 310 students not from Texas, but are athletes. So if we know the total amount of athletes minus the part that are Texan, therefore we can figure out the part that are not from Texas. If we know that there are 450 total students from Texas and 90 of them are athletes, that means that there are 360 students from Texas who are not athletes. And finally, if we know that there is a total of 550 students not from Texas and 310 of them are athletes, that means that there are 240 that are not from Texas and not athletes. 240 over 1,000 represents 24%, which is the answer to number 14. Let me just move this over here so you can see it. The answer to 15, a group of 100 friends go to their local ice cream shop for a summer afternoon treat. 35% of the friends get vanilla, 25% get chocolate ice cream, and the remaining friends chose strawberry ice cream. Furthermore, 15 of the friends who chose vanilla ice cream, 10 of the friends who chose chocolate ice cream, and 25 of the friends who chose strawberry ice cream also got sprinkles. What is the percentage of all the friends who chose strawberry ice cream without sprinkles? So the only difference here is that now on the original division, we're going to have 3 groups rather than just 2. So we have to split the original 100 friends into vanilla, chocolate, and strawberry. If there are 100 friends in total and 35% of them chose vanilla, that means 35 of them got vanilla ice cream. 25% of 100 is 25, and 40% of 100 is 40. From there, we know that 15 friends who chose vanilla ice cream chose sprinkles. If there's a total of 35 people who chose vanilla ice cream and 15 of them chose sprinkles, 20 of them, or 35 minus 15, would have not chosen sprinkles, chosen vanilla ice cream with no sprinkles. If 25 of the friends chose chocolate ice cream, and they say 10 of them chose sprinkles, that means 25 minus 10, or 15 friends chose chocolate ice cream with no sprinkles. And finally, if we have a total of 40 friends that chose strawberry ice cream, and they say that 25 of those chose sprinkles, 40 minus 25, or 15, must have chosen strawberry ice cream with no sprinkles. So our final answer there is just going to be 15 out of the total 100 friends, which is going to be 0.15, which is written as a decimal as 15%. If you have any questions on anything that we've done today, then please let me know either in the comment section or you can get a hold of me on social media. I hope you have a wonderful day, and if these videos are helpful to you, then please like, subscribe, and share with your friends. Otherwise, Dr. Tachi, you want to say goodbye to everybody for a cookie? Come on, you were very good. You just slept the whole time. Come on. You want to say goodbye? Come on, can you say bye? Say bye. All right, very good. All right, thank you guys very much for watching. I hope you have a wonderful day, and I'll talk to you all tomorrow.